Okay, so I think we're going to go ahead and get ready. Just make sure we're getting good audio here, so that's good. Okay, Chad, do you mind pulling the door closed? So thanks for coming out. I hope everyone's had a great day. Apologize for being a few minutes late to start. Things got unplugged. Obviously, we want to thank our sponsors. This has been, I think, a pretty good turnout. Definitely give your feedback to the planning group, because every year we try to make this event a little bit better. So your feedback is very important. So today we're going to spend this afternoon talking about lighting, and lighting is obviously a pretty big part of our modern existence. If we think about kind of what got us here, we start in the late 1800s with this guy, Thomas Edison, who didn't necessarily invent the light bulb, but he created he's credited with sort of the first commercially viable light bulb, and that had a lot to do with the filament he was using and the method of producing that. About 20 years later, there was a gentleman named William Newton, and he is the patent holder of the toggle light switch. So this is the forefather to our modern light switch that you see in your homes and offices. Fast forward about another 60 years, and we get this, right? This was 1985, and the patent on this is called an acoustic device for controlling one or more electronic devices. And so this was, sort of a novel idea. And if you're a child of the 80s like I am, you remember the commercials with the elderly woman shutting the lamp off on her bedside by clapping. And so that was kind of rooted in our cultural history for that. A few years later then, in 2012, the Philips company introduced a product called Hue, and so this was one of the first in the sort of space of connected lights. And so that's part of what we're going to be looking at today. In 2 years later after that, 2014, was when Microsoft introduced Cortana. Again, this originally came with Windows 8.1 and was, but now in Windows 10, it's available really for all the Microsoft platform. As obviously, they're not the only player in this sort of voice space. There's Siri on the Mac. There's Google Now. And then if you've noticed, Amazon just released a product called the Echo, which is also a voice-controlled device as well. And of course, that brings us to today, where we're going to kind of tie all these things together and really talk about lighting. And as I sort of thought about lighting, the fact is that, in my opinion, getting lights to work was a little bit like writing software. This is an example of putting two developers on the same project. Each kind of brings their own approach to that project, has their own view of the world. This one I call deploying into a legacy environment. It's hard to tell from this picture which was first. Was the switch there first, or was the molding there first? But something had to give. There was a compromise made. This one I called the UI upgrade. And we've probably all been in that project. And then, hopefully not many of us, but I think many of us, in fact, have been on this kind of project, where the customer said, this is where we want the wall, and they were unable to change their requirements. The developers clearly didn't have the right tools for the job, so they kind of improvised. QA went right out the window because we had to deliver on time, and this is the kind of result that you get. It's very clever, it's very innovative, but we wouldn't consider this a successful implementation. So, thinking about lighting and switching, and again, this is something that's very commonplace, but I thought, we've got to move past these sort of tired old paradigms for how we turn lights on. And when I really realized what I was wanting to do was just how do we over-engineer this to death? And that's what we technology people do. You know, we look at a problem and it might be enough to solve that problem, but we're bigger picture. We want to find ways that we can leverage technology and do things in new ways. And so that's a lot of what we're going to kind of walk through here today. And so the kind of path we're going to take, we're going to start with a microphone and talk into that. Cortana is going to hear those commands and interpret them and then pass them off to a Windows 10 application. So that'll be one part of what's running on this laptop here. That Windows 10 app is going to reach out over the wire to the Azure cloud and actually put some things onto an Azure Service bus. So we'll talk a little bit about how that is formed and what the service bus is used for. The service bus will, when it receives a new message, will make a call back out to anybody who's paying attention and has subscribed to those messages. So that's going to reach back over, in this case, back down to the laptop. So we'll have a console application that'll be the receiving end of that message. That console application is going to talk to the Philips Hue bridge, which is hidden under the yellow crate. And so there's a hardwire connection from the laptop to the network where the bridge is. And then the bridge uses radio frequencies to interact with each of the bulbs. And so if we do everything right, we'll hit the bulb, and ultimately that bulb will react to the things that we're doing. So it's simple enough to have a switch to turn the light on and turn the light off. But when you bring all these parts and pieces together, you know, lighting is just one example of, I think, a great amount of potential for home automation, for remotely controlled devices, things like that. So we'll kind of approach this, and again, we're over-engineering this. This is so, you know, 1998. So we'll kind of break this talk into really three parts. We're going to start on the Windows side, and we'll talk about Cortana, how to add voice control to your applications. Then we'll talk about the Azure side and look at the service bus there. And then finally, we'll look at the Hue API and how to receive the messages out of the Azure cloud. So that's where we're going, so let's go ahead. I have pre-published a blog article that, actually that's not the right URL. I'll give the right URL. I've pre-published an article that will have the recording of this talk, it'll have the slides, and it also will have all of the articles I used as reference for preparing for this. So there's a lot about Azure Service Bus, there's a lot about Cortana, a little bit about Windows 10 development as well. And okay, so let me switch over here. Okay, so in my project, we'll start off just kind of looking at how this project is structured. So I really have three main projects. So at the top there, you see the Cortana Light Controller. So this is the console application that'll receive the messages from Azure. The Light Listener is the Universal Windows app, and so this is where we will be sending the commands and interacting with the voice side of things. And then our last assembly here is a wrapper around the Hue API. And so this is going to be will sort of flow through to interact with the bridge for the lighting. So I am not a XAML developer. I learned a lot about how that's kind of structured in the process here. But if I go ahead and run, let's see if I get a good build on this. Despite all my efforts to pre-stage all of this, I had to unplug and it sort of reset everything back. So let's go ahead and try to run this guy. So one of the things that I found it's pretty important to realize when you're dealing with Cortana is that Cortana is just really serves as an entry point to your application. So that application can be, in this case, like what we'll do, which is one that has a user interface, or it could be something that runs in the background. It could be sort of an app that runs that there's no user interaction, and Cortana is the main entry point for that. But really what we're doing is we're going to be associating activities with the user interface to corresponding voice commands. And so I wanted to kind of show what the UI does first, and then when we look at binding in the voice commands, you'll see the overlap there. So this is a basic tool. It's got a big button to turn things on, turn lights off, and then each of these individual bulbs has a name associated to it, and so we can toggle each one of those on and off. And if we were to step through what happens when I click on one of these buttons, we'll look at the toggle here. So one thing I found, I'll point out, is that Windows 10 does not yet have a prepackaged Azure SDK. And so if you're not doing Windows 10 development, then you have a nice prepackaged SDK you can pull in from NuGet. I do use that on the console application. But for this side, I'm actually using the REST API. So when I set this up to respond to a click event on the UI, ultimately all I'm doing is sort of capturing some parameters and sending a message up to the cloud with an HTTP call. But let's kind of dig down into that to see how it sets up. So in this case, where I have that toggle switch, I'm sending the control in so I can detect the state of it. Oh, I haven't clicked the button yet. That would help. Which one did I do? Bedroom. Okay. So when I click the UI switch, then I get into here. I send the command and the control down. And this is really pretty straightforward. So, you know, Azure is nice in the sense that it lets you really define however you want your message and your payload to be. And so for my purposes, what I really needed to know was what is the action that I'm going to take, in this case, turn on or turn off. And then optionally, I wanted to send in if I'm targeting an individual bulb in this case. So you can see the structure there, that the dictionary we set up with properties, so all of the sort of details of what the message is going to contain and therefore how I'm going to respond to that message on the receiving end is just a set of key value pairs. And so by setting this up where, in this case, where I check the property of the control on the UI, and then based on it, I can put an on command or on action, or I can do an off action. So this is, again, I hope what you find from this is that it's very straightforward. It's really not complicated at all. You just have to kind of think ahead of how you're going to structure your messaging and how you're going to structure the voice commands when we get to that point. So I basically just build up a dictionary with my action value, and then I've passed in the name of the light as a parameter, so I add that on as well. And so then we can just kind of jump down to this. I have a little bit of logging to the UI. And then in my send message, again, if you've done any sort of REST-based API interaction, you know, we just basically kind of have an address that we're sending it to, and we're using the HTTP client to submit that out. So one of the things we'll see on the Azure side is we have the base addresses for our sort of Azure account, and then the value there that's called the topic name is an indicator for sort of which queue am I posting this message into. And so the idea is that you could have multiple forms of messaging, maybe one for lighting, maybe one for your heating and cooling system. So it's sort of a categorization of the messages that will be grouped together. And then as you see at the end, the sort of entry point to the API is called messages. So that's the URL that I'm going to be submitting to. And then as we get into the details of building out that HTTP client, we do have an authorization token. So that is part of the buildup of the UI, was actually to authenticate into the Azure service so that I have a token to pass along, indicating that I'm able and authorized to submit a message to that service bus. And then again, for each of those values that I put on the dictionary, I just kind of build it up on the HTTP header and then submit it up. So if that works, then we should get a good response back, and then the rest of the UI here is just kind of presenting that back out. So in our logging, we see we received a command, and then we got a positive result back. Okay. So all of these buttons essentially do the same thing with slight variations on either the name of the light that we're controlling, or in this case, if I do one like the turn lights off, it would be basically iterating through, or in this case, it's just giving a generic off action and not indicating a particular bulb that we want to control. And so these things just get submitted up to the cloud and basically queued up and are waiting for us to receive. So it's pretty straightforward. And so when we want to look at the voice side of things, Cortana really operates on what's called a voice command definition file. And so what this file does is essentially allows me as a developer to define what is the terminology and the phrasing that I want to use to trigger Cortana to act upon my application. So the first thing I have to indicate is this here that's called the command prefix. And so if you just wake up Cortana and make a statement to it without indicating sort of or qualifying that, it's going to assume you're just wanting to do a search. So it will take the text of the terms that were said and run a internet search against them. So in order for us to be able to tell Cortana, hey, don't just generically run a search on this term, but interact with our application, we have this prefix. And so again, this is arbitrary for you to declare, but when we have to use that as kind of a trigger phrase to tell it like this, everything that follows is going to be a command for this specific application. So that's the first part we have to define. And then we come down here into the command definition itself. So we have a command name, and that is, we'll see how that comes back on the interpretation side of the voice command, but we group the command together. And then really the phrasing, the semantic phrasing, is this one here called listen for. And so this is the actual sort of speech pattern that I'm asking Cortana to pay attention to. And you can see at the end there I have a placeholder for essentially a variable term that's going to go into that action placeholder. The feedback node or property there is how Cortana is going to respond and basically state the command back to me. So again, I can sort of form this or phrase this however I would like, but the listen for is going to be the terms that I will say, and then Cortana will respond with the feedback term. So that's the all lights command where I'm just providing an action. And then you can see here I have another one for the specific light where I have a placeholder for the name of the light itself as well. So I have two variables. One thing you come into then is the next section here, which are called the phrase lists. And so this is where, again, we're kind of defining in advance what the acceptable terms are for each of those placeholders. So for the action command, we are accepting an on value or an on word or an off term. And then for the light name, you can see I actually hard-coded in the names of the bulbs. So I believe there is a way where you could build up the phrase list on the fly so that it's not hard-coded, or through some configuration or through some user interaction. So if you were doing this as a consumer application, we don't know what you've named your light bulbs. Maybe we give you a data entry screen where you provide the names of your bulbs and then we register them as part of the voice command. The other thing that I wasn't sort of applicable in this case, but would be appropriate for some other scenarios, would be to have a value, a placeholder in the command that would be essentially just a variable. So if I wanted to say something like turn the heat to 72 degrees, right, that 72 would be a variable that I want to capture. And so I don't know exactly if you'd have to define the phrasing for all of the potential choices, or if it's smart enough to sort of just have that as a placeholder and just return back whatever was said. Everything we'll see from the speech recognition engine essentially comes back as a string. So you're sort of left to figure out how to do string manipulation or string comparison to be able to interpret what was actually said. So that's I just want to point that out, that the flexibility of these commands may be, in fact, that you could do more open-ended or more arbitrary values as part of that. So once we've defined the command structure, the next thing we have to do is register it with our application. So in XAML, there's a file called the app XML. And this, if you're a web developer, this is sort of similar to like the global AX. So this kind of governs the whole application. And so part of one of the event handles that we have here is on launch. So this is what fires basically when that splash screen was being displayed. And it's kind of the setup for your application. So what we need to do down here, as part of that launch, that buildup of this tool, we need to register the voice control file with the operating system. And so these two lines of code here, the first one just locates the XML file on disk. They do have a mechanism for using a URL, so if you wanted to have your voice commands externally and reference them over the wire, there is a mechanism for that. And then essentially we are installing this command definition file and passing that over to the operating system, to the underlying runtime for this application. So I'm assuming, I haven't tried this, I'm assuming this is kind of a one-to-one relationship between the command file and the application. But it may be that you could have multiple sets of commands and register them, or configure, based on a configuration, say, okay, you're an administrative type user, so you get a greater list of commands or not. So you may be able to segment this out or put some logic into how these voice commands are registered as well. So once we've registered it, then we have to wire up how to interact with Cortana once the voice command has been triggered. And so that comes in the next event, which is called onActivated. And so this is the event that would get called essentially when there's an interaction with the application. So whether I launch it manually and it loads the default screen, or in this case where some other external activity calls into the application, it's going to come in on this onActivated event handler. So we do a little bit of build-up here that's similar to the onLaunch, just to kind of get the windowing mechanism ready and load and get the page ready. But then we come in and we can interpret, really using this item right here called the kind. This is indicating how was the activation triggered. And so we can see here this line of code that says if we are not being activated from a voice command, then just go ahead and carry on and load and activate the window. If we get past that, meaning we are activated by a voice command, then we get into now the process of interpreting that voice command. And that's where the speech recognition comes into play. So there is, when you start doing voice commands, you'll get prompted, and you can reference, I think it's also in NuGet, for the Microsoft Speech SDK. And so again, this is a prepackaged library you can include in your application, but it includes essentially all of the speech recognition handling that Cortana uses. So we start by setting up this result object, and that represents, as part of the parameter that is coming in to our activation method. The first thing we get out of that is the voice command name. So this is going to correspond and be indicated back to that XML file for which command set was triggered. And so these name values are passed along to us because Cortana is going to say, okay, based on the terms that you said, you match command X or command Y, and I'm going to pass which one you matched on into the application. And that's important because we might want to translate and behave differently based on what command was actually spoken. So we get the command name, we get the actual text that was said. So just again, as a string, it's going to give me the string representation of the words that were spoken. And then it's pretty straightforward. We're basically just going to say, okay, based on what command was called, then let's interpret this accordingly. So the real secret sauce is this guy right here, which is the semantic interpretation. And this is where it's basically parsing the words that were spoken, represented as text, and finding that placeholder that we defined in our command definition, and returning back to me whatever the value was that was put in that placeholder. And so so this is where, in this case, when we have the command and the option was on or off, we're going to get back from the semantic interpretation what value actually was given. So again, it's all string based. So you have to kind of know the best approach to kind of standardize those, whether through constants or some other sort of library of terms. But you'll get the value out that matched on that placeholder. Part of what XAML likes is containers to pass in between the pages of the app, and so we have this little light listener voice command defined that basically just kind of takes all the properties from what was given to Cortana and packages it up. And then we designate what our destination page in the application is going to be. So this would be where, depending on maybe the spoken term was a search, and so you'd want to send it to the search page, or a spoken term was a retrieve, and so you want to send it to the details page or something like that. So you can sort of route the user to different parts of your application, again, based on the voice command that they issued. So again, this is all happening during the activation process of the UI. And then finally at the bottom, we're just going to do that navigate. So we're basically going to pass into the page that was designated. And in this case, again, we're sending that light command as a parameter to the specific view that we want to see. So that kind of processes us back over to the code behind for our UI page, and when the navigate event happens, it triggers an event handler on the page called onNavigatedFrom. And so again, this is sort of indicating that, hey, you're being called from somewhere else, and there's a parameter that's passed along to you. So again, here's where we retrieve that parameter off and pass it into our own command interpreter that is then going to determine what messages we want to put onto the service bus. And so again, this is not terribly complicated, but we basically are looking to see, was a light name parameter provided to us? So we want to capture that. And then similar to what we saw on the individual button click, we're basically just preparing that dictionary of terms, and we're sending that message up over the REST API to the cloud. So let's sort of see how that all steps through. I'll start on the activation side. We'll put one here just to get us started, and then we'll do one on the handoff to the page as well. Okay. Okay, so I'm running my application. I can interact with it directly. We already saw that, and we're sending messages to the cloud. So the entry point for Cortana, there's a little bit of configuration. Again, this is Windows 10, so there's a little bit of setup to kind of get this activated. But once we're in here, then I can trigger the microphone. You remember our definition, the trigger phrase was Code Camp. So I can use a phrase like, Code Camp, turn the lights on.
Okay, turning the lights on.
Okay, so it responded back, turning the lights on, and now we're in, it's calling into our application. So we're coming in on that activated side. It's already interpreted out, so our voice command, we were using the generic form, so it's giving us the all lights command was provided. And so then as we drill down into this, we can parse that out. So if we look at what's actually put into this object that's going to be passed over to our view, you see that okay? So the action is on. The command mode was voice, so again, this was triggered by a voice command. In this case, the light name was not indicated, so that's empty. It gives me the actual text that was spoken and what voice command was provided. So I'm passing all of this payload to my actual UI page to further interpret and determine how do I respond to it. So, so let's go ahead and run that. We should break on the other one. Okay, so we've come in on the navigated from. We've determined that we have a parameter. We've pulled that parameter off. And then as we come into here, whoops, sorry. Then again, I'm sort of parsing out what those options are and building up that string to send up to Azure and put on the wire. So, so really pretty straightforward kind of interaction. It just, you know, what I found is that it just, you got to think ahead. You got to be able to sort of plan what your terminology is. You got to plan what your syntax is going to be. But Microsoft has done a great job of really, you know, making it simple to add voice commands to an existing application. I was talking to some of the guys last night at the speakers dinner, and they had done some of this, and it seems like that voice command file has not changed a whole lot in several iterations of it. So if folks that were doing voice recognition on the Kinect, it was still using a very similar construct to define the commands and to interpret them. So Microsoft's done, you know, the whole speech engine. I would imagine the speech recognition has improved over time, but the mechanisms for leveraging it appear to have, you know, stayed pretty consistent with previous versions. Any questions about that before we move on? Okay. So go ahead.
Potentially you have multiple applications on the phone, right? This one is for Code Camp. Let's say you have a second one. Would all that configuration be in the same font? It has to, right?
It could be, yeah. Where if you had different command sets, maybe different trigger words, is that?
Yeah, I mean, you have two applications, right? With the two command sets, right? One you activate with Code Camp, the other one you activate with something.
Yeah. Yeah, I believe, so the question was, you know, if I have different sets of voice commands, can I put them in the same definition file? Yes, so long as all of those commands get bound to the same application. So that register part is where everything in that command file is going to be associated to that application. Now, you can choose to ignore them if it comes in.
Actually, my question is different. What I'm wondering is, do you have to put it in the same, or can you keep them separate?
Yeah, so again, the relationship between the file and the application is at least one-to-one. It might be multiple definitions to one application, but but the register, again, so you might register multiple files and then in your application ignore commands that aren't relevant.
Yeah.
If you wanted to just have everything in one XML file, that would be an approach as well. So.
Yeah, the other question I wanted to ask you is, let's say you are building an application where you want to take a command, and then based on that you want to, essentially you have a decision tree kind of.
Yep.
You want to ask this question or the other question, right? I mean, it's more of an interactive thing before you can make a decision.
Yeah. So again, like the question is, how would you have more like multiple passes before you act upon it,
It's
right?
complex.
Yeah. So yeah, that was, I don't know the answer exactly because in fact, that was part of the topic we were talking about yesterday. Was like, the example was if you had an MP3 library. So your first command would say, well, I want to play this artist. And then your follow-up command would be this album. And then your follow-up command would be this song, right? Can you chain those together before you send it to the application? And I just don't know how that would be structured in the command definition file. Like if you can capture it and hold on to it and then wait for another one, if it is back and forth like that. So I can help. I'll look that up and try to find the answer to that. Okay, so we've had some UI. We've sent a bunch of messages up to the cloud. So let's kind of look at how that is set up. And obviously this is not a full-on Azure talk, but the thing that we do is we start off with a service bus. And so if you are on Azure, you've got this little kind of category called service bus. And then we define a namespace. And so the namespace is kind of what, again, defines our URL structure. What they've done here is actually pretty interesting. So there's different flavors of these. So a queue is essentially a first in, first out sort of pass through, right? So I can put a message on and then the next, it pops right off the other end. When I'm consuming a queue, I have to go ask, is there another message? I have to have this polling kind of mechanism to go determine if there's anything on the queue that I want to act upon. And then I pop that message off and I can interpret it. The one that we're using is called a topic. And so this is more of a publish and subscribe model. So I define a topic and then I can register as a subscriber to that topic. And when a new message comes on, Azure is actually going to push out to any number of subscribers and trigger that automatically. And so we'll see in a minute when we drill into that. This other one called Event Hubs is very much Internet of Things oriented. This is really a structure for collecting data from a device. So if you had something that was taking a temperature reading every hour, you would submit that value to the Event Hub and it would aggregate and be able to then give you a query language for saying, okay, for this device, give me all the data over a time horizon and things like that. So some of these more real-time analytics or trending kind of data is what the Event Hubs are oriented around. But we're using a topic, and so in our topic, again, we've defined the name of a topic, which in this case is Hue commands. And then when we get into the details of the topic, this is where we're going to see things like the URL entry point for that topic. There's a whole process you go through here to essentially set up the credentials. And so you set up a credential for who is submitting to the queue, and then you set up a credential for the consuming side, the subscriber side. So anybody who wants to subscribe to this has to authenticate in to be able to receive messages off. So there's authentication that happens on both sides. And so once we've got all this set up, then it's a little hard to see. They don't really give you a good mechanism for sort of actually looking at the items on the queue, but you can see these kind of metrics for things like incoming messages, how much data is being passed through these, and things like that. So through the management portal, you can't sort of like see the list of actual messages and interrogate them, but you do get some metric on the traffic that's flowing through the queue as well.
Is it possible to get it some other way?
Like some API that exposes?
Yeah, there, you know, you can, if you, in this case, like if you were a subscriber to this queue, you'd automatically get a push for it. If it was more of an asynchronous one, you can query the queue and pull it without taking a message off of it. So that's part of the retrieving process, is whether you want it to automatically pop it off, never to be used again, or if you just want to manually do it, and then you could just look at it and then walk away from it, and it would leave it on there. So the last piece of the chain here then is our console application. And so again, this is not terribly complicated. Essentially what I'm doing, so again, in this case, I am able to use the Azure SDK, because this is not a universal app, this is just a .NET application. And so, so that gives me this, subscription client. And so this is what is establishing the connection between my application and the service hub that I've designated. And so we sort of initialize this from the connection string. So you can see the parameters here. I read in the connection string, which is part of the authentication process. It actually gives you back a connection string that will be used. And then the topic name is the one that we want to listen for, or we're registering into. And then the service bus subscription name, again, is kind of what correlates the you know, which authentication key am I going to be using to connect into this. So once I have that defined, and again, I just read these values out of a configuration file, then I can establish my client, and I can, you know, there's a couple parameters here that we can do. So one is how often does it poll? It sort of has a keep alive. So again, once you're connected, in order for the push mechanism to work, it has to stay connected. And so this, the renewal timeout just kind of makes sure that it still is actively listening. The concurrent calls there, you could actually have it pull multiple messages off at the same time. We're throttling it to just one at a time. And then the autocomplete, again, is whether I automatically, after I receive that message, do I take it out of the queue so that nobody else can process it at that point. We're choosing that to be false, and that's part of our error handling, is like if we try to process this message and it fails for some reason, I want to be able to retry it. So again, depending on the application, that might may or may not be the scenario you'd want to use. So once we get our connection, then we really just kind of set it off, and we have we define essentially an event handler that says when you get a new message pushed down to you, here's how I want you to process it. And the message structure we'll see when we debug through this is going to be very similar to the structure we built when we were submitting it up. It'll have a name, and it'll have a collection of properties that will be then passed down to us. So part of what I'm doing just for logging purposes is I'm cycling through each of those properties and writing it out to the log so I can see what was received back. And then I get this process message where I can then provide my logic for how do I interpret this. So this is where unpacking the message that came off of the queue, and I really have sort of four cases here. I have, it was the command turning on or turning off, and then did an individual named light get provided or not. So, so that's kind of the structure of my logic here, is to say, you know, which scenario or what interaction with the API for the bridge am I actually going to call out. Again, it's not terribly complicated. It's just sort of planning ahead and figuring out sort of what the interactions are going to be. So my wrapper around the API is this one called Hue Manager. And one of the things I do when I initialize this application is I actually connect to the bridge and I query it to say, give me back a list of all the devices that are connected to the bridge. And I put those into a named list so that I can query it by name, by the light name. So again, this is a little bit tricky because it's all string comparison. So if I have in the bridge, if I name things with one casing, but my voice definition file, which it contains the value that's going to get submitted to the queue, is different, I have some string comparison that I got to just account for and make sure that I'm handling that well. In the case of the Philips Hue API, it is also a REST-based API. So we're doing a very similar kind of structure here where we set up a set of commands that get serialized and then sent over the wire to interact with the bridge itself. And so we'll see that as we step through it. So in the case where all of the things we're doing here, we're essentially we're using the put action on the API to say we're essentially updating the value of a bulb. So we're updating the data structure they offer is called the state. And so the state object has on or off, it has what color is assigned to it, it has the name of the bulb, it has some other properties that are there. And so all we are really doing is saying, hey, I want to update the state value from on to off. And then the bulb knows how to respond to that change accordingly. So if I run this through manually, we should be able to see, since we've already got a couple messages queued up in the service bus, we should be able to see these come down. Let's see here. Yep. So again, I have the address of my bridge, and there is an authentication token for the bridge as well to be able to connect to it. So I have that stored in a configuration file. So we can see here it's attempting to connect to Azure. Hopefully this will work. Okay, so we made a good connection, and since there were messages already there waiting for us, it immediately triggered the on command. So it said, hey, I got a new subscriber. I've got stuff waiting for you, so it pushes it out to us, and that triggers this on message handler. And so if we look at this, this message object, we should be able to see some of the details of it, I think. Obviously, there's a lot more information in here that's relevant to the queue, but we can see here is the properties collection, and we see that we have this one here called action is on. So the message that we submitted up is basically getting relayed back down to us in the same form. So we just kind of, again, I jumped through these to write them out to the log. And then here's where we drill in to interpret them. So if my action is on, then we want to determine if it was targeted to a specific bulb or not. In this case, it was not. So I'm just iterating through all of the bulbs and sending that same command to them. So since the lights are already on, this isn't going to change anything for it. So we'll just run that through. The next one should come through here, and we'll see where this one goes. That's also an on, so that's not going to do anything. Did I do an off? Let's see here. There's an off. There we go. Okay. So if we look at our console here, you can see where it's kind of revealing out. So we get a new message right at the bottom. We have an action for off, and then we iterate through each light and send it the off API call, and send that through. So
What were those error messages?
it was basically a timeout for popping that message off the queue. When you receive it off of it, it basically puts a lock on that record, and so when the lock expires, you can't change it again. So because we were debugging through it, it expired that. Okay, so maybe a couple other, so there was an individual light command that came through. Go ahead.
So if you had an app which was, it was critical that you get a feedback, that it should happen.
Yeah.
Would that be possible?
You could, in the sense where this app right now is just a receiving side. But in that case, you could have this to say, okay, I've processed this message, and I'm going to put a message back on maybe a response queue to send it back the other direction. So that would be the way to get some bidirectional, where you'd have one queue for inbound commands and one queue for outbound responses, would be how you'd probably look at doing that.
And on the client side, you would have to poll for.
Correct, yeah. So you'll notice when I brought the other one up, when it first started, it had all the switches in the off position, even though the lights were on. It's because there was no direct connection between that client and the state of the bulbs. So, so yeah, you'd have to do a different kind of polling mechanism to retrieve that back over the wire to your UI application. Yeah. And there's lots of cases where you know, the thing about using the service bus as the intermediary is that, as we sort of talked about, it gives you lots of opportunity for having different categories of commands, right? So you can have, you know, here's ones for lighting, here's ones for open or close the garage door, here's ones for water, you know, for different types of commands. But it also lets you do, you know, multiple receivers. So you could have one entry point, and you know, if you have this in multiple buildings, since it's all distributed over the internet, you could have a very broad interaction with a lot of devices. So if you were just doing this for, you know, your own personal home space, it's a little bit of overkill to go out to the cloud and come back in. Though it does open up, like if you wanted to have a mobile application or other UIs that submit onto the same bus, then you open that up as well. So again, it's very, you know, the parts and pieces are not that complicated, but how you assemble them and how you plan them out is really where there's lots of opportunity. So go ahead.
Do you have multiple listeners, subscribers for the same message? What happens to the message after it is processed? Is it out of the hub?
Yeah, so I sort of moved on past that before, but at the bottom, after we process it here, we do this message complete. And so that's what tells the hub to take that message out of the queue. And you can see here on the error handler, if we encounter an error on it, then we do message abandoned, which leaves it on the queue so that it can be reprocessed. So, so again, we're doing it manually. There was that setting when we set up the client, this one here called autocomplete. If that's true, then it will automatically pull that off, never to be used again, as well. So that's a configuration of the connection. So, yes, sir.
So I just heard you say that you can implement a service bus internally to take Azure out of the picture, if you want.
You could. It wouldn't be Azure, obviously,
Yeah, it could be.
but you could have your own asynchronous kind of queuing mechanism, server-based or on-premises based, that could function the same thing. Yeah. Yeah. Go ahead.
Is there an on-premise equivalent on the Azure cloud that would take care of the local?
Well, in the old days, it was called Microsoft Message Queue, which was a server-based queuing mechanism. I believe SQL Server has some publish and subscribe behaviors that you could use as well. So you could write a record to the database and then have subscribers be notified of that kind of scenario. So yeah, there's a couple different, you know, the transport mechanism for the message is somewhat arbitrary, as long as it's defined and received on, you know, using the same sort of structure, then you could set that up a lot of different ways.
Question.
Yes, sir.
So your message completed, is that just a software action where the system says, yes, I got your message and I did it? But does the hub actually go and query the bulb? Are you actually on, or are you broken? Is there electricity there to really say message was received, it was activated, and it worked?
Yeah. So again, the question was, you know, are we getting status back from the bridge on whether it was received and processed properly. And again, you could build that in. We do have in our, so that was our last command, man, we queued up a whole bunch of these here. So in the wrapper for the Hue API, again, we are, if we encounter some error, I can't connect to the bridge, that bulb was not found, or there wasn't a bulb in the collection with that name on it, then that would throw an exception that we could handle and interact with. And maybe, again, that's a way to put a response message back out, to say, hey, we tried, but we couldn't get to it. What's interesting about these bulbs, too, I found is that if they're powered on but turned off, then again, there's still an interaction with it because it's that state variable that determines whether it's on or off. So if the bridge doesn't have power, then the API would just not be able to connect to it. But if the bulb doesn't have power, then it probably would return and say, hey, I can't find this device by ID or by name. So.
Is the bridge using X10?
Philips uses, I believe, the Z-Wave protocol. There's a number of them, but I think Philips uses the Z-Wave. There's another one called Zigbee that's a similar. So these are all somewhat proprietary or somewhat, different protocols for the radio communications between the devices. So, okay, so let's put the icing on the cake and do this all end to end. So what I'm going to do is I'll run the console app directly. So that should connect back up for us here. And then we will we'll put this one in debug mode. Actually, I'm going to clear all my breakpoints. Okay, so we'll start just with the button clicks. The lights are on, so we'll do an off command. And you can see, the latency on this, on the messaging side, is pretty quick. This one has to wake up and connect to the bridge, which might take a moment. So again, the latency on sending it to the cloud and receiving the pushback was almost instantaneous. So that works as advertised. Yep, so let's try this again. Let's see here. I found this when I was prepping for it, that sometimes this takes a minute to wake up. Okay, new message received, action on. I can do this another way, so just I'll kill it from here.
Cat is in the fireplace, right?
Yeah. There we go. Okay. So yeah, so it's got a couple of these queued up. So there it goes. So that was just a connectivity, getting that synchronized up. So So now we want to, so we can turn individual ones off and on, so that all should work as we'd expect. So now we can do the voice, and if you configure your Windows to be such, Cortana can listen and activate on its own, so we can try that. Hey Cortana, Code Camp, turn the lights off.
Sure, turning the lights off.
And so we should see that all the way through. How about that? Good. So a few minutes over, but any questions before we wrap up? Yeah, go ahead, Mike.
What's the privacy concern?
Yeah.
Cortana listening for activation and post-activation. I just read Microsoft's privacy page, and they are keeping recordings of your Cortana.
Sure. Yeah. Yeah. So the question was, if I say something to Cortana, how private is that conversation, right?
Or if I don't say something to Cortana, but it's listening.
It's listening anyway. Yeah. So I've heard this scenario not specifically with Cortana. I've heard it with some televisions. They have these smart televisions now that are network connected, and I think there was one brand, maybe Vizio or one of the Samsung, where they were defaulting the microphone on, whether you configure it or not, and then it was sort of, listening to what was going on in that room. So I can't speak for Microsoft's stance on it, but I believe a lot of the speech recognition is submitting that to the cloud to get a response back. So yeah, I would assume there is some collection of that data in order for them to improve the voice recognition as part of it. I mean, that's the positive spin on it. But yeah, I mean, I think you'd assume that whatever you say might live on. It's a good question, though. Yeah, go ahead.
Is there anything with iOS or Android in voice recognition?
Like for Siri or those? Yeah, so I have not. And it was actually one of the questions I thought of during the process here is does Siri have a similar mechanism for allowing me to register voice commands into it? I just don't know the answer to that, but it may. I would think that it would, if you want to have a similar kind of hook from Siri into your iOS app.
Right.
I just don't know if they expose that or not.
So I just attended Chad's presentation on cross-platform mobile development.
Yep.
And it was really good that you could write code that would run on all three
Yeah.
platforms. So I was wondering if there's a cross-platform voice recognition effort underway.
Yeah, that's a great question. I mean, if you're doing Windows Phone, then again, this universal app is going to deploy to a Windows Phone just the same. So you would get Cortana support, but for the other platforms, I don't know what their voice hook mechanism would be.
Is the Windows Phone in your estimations, going to regain any market share, or where do you see that going?
Yeah, I don't know. Didn't they lay off all the Nokia employees? So I don't know where this is actually going to turn out. Yeah.
So this would be used for voice recognition on a tablet, or
Yeah, you could do it on a Surface or a tablet, or certainly a Windows PC. The big question is like, how do I rig this up in my home, for example, right? I mean, do I put listening posts all through the house that all feed back to the PC? Does it only work if I'm in the same room? Those are kind of the other aspect of this that make it hard to fully implement across the board. So, but go ahead.
When you're sending the message to the queue, I noticed that you are putting the parameters to the headers instead of to the body of the request. So is it that's the requirement, or?
That's how the Azure REST API is structured. Yeah. So the body is just sort of the name of the message, but all the properties go onto the header of that. Yep. Yes, sir.
So how does the authentication with Hue work? I remember you
Yep.
mentioning the token. So you would choose the token and can be.
Yeah, so the question is, how does the authentication to the bridge work? And on the bridge, there's a button for linking. And so part of what happens is that when they actually provide a browser-based little API tool. And so in order for me to get a credential back from the bridge, I have to physically push the button while simultaneously making a request to the API. And if both of those occur, then it will return back to me essentially a GUID type credential token that then I pass back along with all of my calls. So Hue and Philips, they have another mechanism for linking the physical device to an account in their service cloud. And so that is what would allow you to sort of discover the device over the wire. So you could have a mobile app go through their service environment and push down to the bridge itself. It's a slightly different implementation than what we did here, where I'm hardwired into the bridge. But there are some, if you look at the Hue API documentation that Philips offers, there is some sections there about the discovery process, like how to actually find the bridge so that you can connect to it. Yeah.
Did you try removing the actions list from the commands configuration, like for the on and off? Did you try
the phrase list?
Yeah. Did you try that?
I didn't try that to see how it would reply those back.
Can you quickly try that?
I can try. We'll let everyone else go. You had a question here?
If not Hue, are there any other similar products?
Yeah. So so the question is are there other similar lighting products? So Hue is the Philips brand product. This kit, which has 3 bulbs, and these are multicolor bulbs. I kind of didn't go into that, but they do have a single white bulb as well as multicolor bulbs, as well as I think they have like the LED ribbon style that are all connected. So the 3 bulbs in the bridge, I think, is about $180. The argument being these are LEDs; they're supposed to last for 30 years or whatever. There's no filament to break. I think GE has a product that's similar. And what's happening now in kind of the overall Internet of Things space is, again, a lot of these manufacturers have each kind of had their own protocols and APIs, and there's been some efforts to try to give it a little more consistency for cross-manufacturer interaction. So if I have a Nest thermometer, for example, can the Philips bridge find it, things like that. So there's a whole class of hardware that's coming out that are just hubs to kind of tie together these different devices. I found another project that's called AllJoyn. It's JOYN, and that is a software discovery framework for being able to kind of go out and find the devices on the network as well. But again, the radio frequency it's using is not Wi-Fi. So you're finding these routers that are Wi-Fi, Bluetooth, Z-Wave, Zigbee, all these different sort of radio protocols in one hardware device, so that you can interact with a lot of different hardware based on whatever protocol the manufacturer chose to implement. So that's kind of the immaturity of the market, I think, right now. I think as time goes on, we'll see some consolidation on those protocols and make it easier. Because again, from a non-technical consumer point of view, like, I don't want to spend a lot of time trying to figure out can device X work with bridge Y. I just want it to work. So it's definitely not quite there yet. So last question, and then we'll let you guys go win door prizes.
Is there an ecosystem and a developer community built around the Microsoft Speech SDK? Is it starting to mature at all, in your opinion?
I would suspect so. So on that that article, let me put my contact info back up. If you go to codeovereasy.com, I've got a page that has all those articles, and so there's a pretty significant section just about the speech SDK that you can check out, and it gives examples of how to structure those voice command files and those sorts of things. So, awesome. Thank you.